Okay, good morning, class. Right. So today we go to the new topic. So yesterday we already finished about the generation. Okay, how to generating, right? How to generating electricity. Okay. We already learned about the induced current, about the power plant. Okay, and also yesterday we learned how to use the CRO, okay, cathode oscilloscope, okay, and how to calculate the voltage, right? And then also at the same time we already learned there are two types of current, alternating currents and also direct current. Okay, you already know how does the shape for the alternating current and also for the directing current, right? So today we will learn about the transformer. Okay, so let's see about transformer first. Wait for a moment. Okay, transformer. So remember when we learn about the power plant, right? Okay, so after the generator, okay, after the generator produce the electricity, okay, so there will be a one device, okay, one electrical device, okay, that used to step up the voltage, okay, or step down the voltage. So step up means to increase the voltage or to decrease the voltage. Okay, so after the generator, okay, after the generator produce the electricity, okay, they will use a step up voltage, okay, to increase the voltage, okay, because the amount that for the amount of the amount of the electricity, okay, that produced by the generator is actually not enough, okay, to be transmitted to the power station, okay, so they need to increase the voltage, okay, so that's the function of the transformer, okay, to increase the voltage. Then after it reach the power at the power at the transmission, okay, at the power transmission there, so and then when it go to our home, it will use the step down transformer, okay, to decrease the voltage back, right? So because our home only need like 240 volt only. Okay, so let's see first what is the transformer, okay, and how does the transformer work, and also how to calculate the voltage, okay, for the step up transformer and the step down transformer. Okay, so the structure and the operating principle of the transformer. Okay, so actually, how does the transformer look like, right? So a simple transformer, it consists of two set of insulated copper wire, okay, wound around a soft iron core, okay, and it's working based on the principle of the electromagnetic induction. Okay, so principle of electromagnetic induction means you produce the induced current by cutting the magnetic fields of line. So we use that principle, okay, in the transformer. Okay, so it's based on the working of the principle of the electromagnetic induction. Okay, where we cut the magnetic fields, alright, to produce the current. Okay, so when an alternating current, okay, it flows through the primary coil, okay. Wait, I see the diagram first. Okay, so this is structure of a transformer. Okay, so you have to see there are two insulated, okay, two insulated wire, okay, here, winding around the soft iron core. Okay, so this is usually we call it as a primary, and this one is secondary. Okay, this is the primary and this is the secondary. Okay, so this is the primary winding, okay, and the primary current flows through at this part, right, and is connected to the alternating current. So you have to remember the transformer only can use alternating current. Okay, so it means you cannot connect the direct current to the transformer, it will not function. Okay, so mean if you put the bulb here, okay, at this voltage here at the secondary coil here, you put the bulb here, the bulb will not light up. Okay, because of the transformer, it needs the alternating current. So why does it need an alternating current? Because alternating current, as you know, it can change the direction, right? So remember I told you, I think like 2 days ago, okay, it will change the direction. The first one, the first cycle they say clockwise, and then after that it reverse back, the move in the opposite direction. So because of the changing of the direction, okay, so that's why we need to use the alternating current. So you just cannot kind of connected the transformer to the, let's say, to the battery, okay, it will not work, okay, the bulb will not light up. Only if you connected it with the alternating current, the bulb will light up. All right. Okay, so this is the structure of the transformer. Okay, so I just want you to see the structure first before I explain about the how does the transformer work. Okay. Okay, so just now we already see, right, the two set of the insulated copper wire. So the first one at the left side and the one the other right side, right? Okay, at the left side we call it as a primary, okay, and the right side we call it as a secondary coil. Okay, so then the when an alternating current, so you see here it say alternating current, okay, it flows to the primary coil. So let's say this is the primary coil, okay, so it flows to the primary coil. So a magnetic field, okay, whose magnitude varies in produced in a transformer coil. Okay, so when the current flows through the primary coil, okay, it will produce the magnetic fields. Okay, so when the current flows into the primary coil, it will produce the magnetic fields. Okay, but these magnetic fields will keep changing. Okay, we keep changing, okay, direction. Why? Because of the alternating current also, it keep changing direction. So when you produce the magnetic fields also keep changing direction. So that's why it said here, when alternating current flows to the primary coil, so a magnetic field whose magnitude varies, okay, the magnitude varies here in produced in the transformer coil, right? So here they will produce the magnetic fields when the current flows through the primary coil. Okay, so let me see the diagram here. So when the current flows here, okay, at the red wire here, it will produce the magnetic fields, right? So here it will produce the magnetic fields. Okay, so when the and you know alternating current keep changing the direction, right? So means the magnetic fields in the insulated core on the red one also we keep changing direction. Sometimes we become north here, sometimes become south here, then it change back, this one north, this one south, okay, and then change back, this one north, this one south, okay, it keep changing the direction like that, okay, because of the changing of the current here, the direction of the current. Okay, and then after that, this alternating magnetic field, okay, will flows through the secondary coil. So it will flows to the secondary coil, producing an induced EMF. Okay, therefore causing an induced current, okay, to flow in the secondary coil. Okay, so this one, after that, the alternating magnetic fields, okay, it will flow through the secondary coil to produce the induced EMF. Okay, so let's see the diagram here. Okay, so now you already know there is a magnetic field produced here, and it's a varies, okay, it's a varies magnetic field. Why? Because it keeps changing the direction. Okay, so it will flows to the secondary coil, okay, through the soft iron core here. So this one you see the box shaped like, right? Okay, this one is actually a soft iron core, and it's easy to magnetize, okay, because this one is a metal, so it's easy to magnetize. Okay, so when this one it has a magnetic fields, okay, with the various magnetic fields, it will transfer the magnetic fields, okay, through the soft iron core and goes to the secondary coil. Okay, goes to the secondary coil. So on the secondary coil here, that will produce the induced EMF, right? Because there is cutting the line of the magnetic fields here. okay, by the coil. Okay, so when you cut the magnetic field lines, okay, it will produce the induced EMF. Okay, and also at the same time, when the induced EMF produce, induced current also produce. So that's why the current flows through the secondary coil. Okay, so I explain again. Okay, when the alternating current, okay, so let's say this is alternating current here, right? For a moment, I find my pen. Where's my pen? Okay, so let's say this is the alternating current. Okay, so this is symbol of the alternating current. And you know, if we keep changing the direction, right? The first one, if we keep changing, we go here, right? Close until here. Then you change back, you go here, go up again. Okay, so because of the changing of the direction of the alternating current, it will cause the changing of magnetic field lines also in the primary coil. So this is called as a primary coil. Okay, so after that, the changing of the magnetic flux there, okay, it will be transferred, okay, it will be transferred to the secondary coil by the soft iron core. Okay, it will be transferred, okay, to the secondary core by the soft iron core. So this one we call it as a soft iron core, right? So it will transfer that to the secondary core. So at here, the secondary core will produce the induced EMF. Okay, so when you produce the induced EMF, means the induced current also produced. So that's why the current flows to the secondary core. And let's say if you connected it to the bulb, okay, so let's say we connected it to the bulb will light up, right? So this using the electromagnetic induction, right? So the alternating current produce the various magnetic fields, okay? The various magnetic fields, and then the magnetic fields be transferred to the secondary core, all right, by the soft iron core. Okay, and then here, okay, after it transfer the magnetic fields here, the coil here we cut the magnetic fields and produce the induced EMF, and also at the same time it produce the induced current. So that's why the current flows through the secondary coil, and also it light up the bulb. Okay, so that's the function. How does the transformer work? Okay, so let's see for this one. So here I already explained it flows through the primary core. So the magnetic field whose magnitude varies and produced in the transformer core. So these alternating magnetic fields will flow through the secondary core and produce the induced MF, then causing the induced current, okay, at the secondary core to flow in the secondary core winding. Okay, so this one I already explained how does it works for transformer. Okay, and the symbol for the simple transformer. So this is the symbol for the transformer, right? So this is the primary coil. Okay, primary coil, the red one just now I show you in the diagram. The one is a primary coil. Okay, and this one actually the symbol like a straight line here is a laminated soft iron core, and this one is a secondary coil. Okay, this is a secondary coil. Okay, but there are two type of transformer. Okay, the first one is a step up transformer and the step down transformer. Okay, so we will see later that one. Okay, but this is the symbol of the transformer. Okay, okay, so this is the label. Okay, so I already told you this is called as a primary coil. This is the secondary coil. Okay, and the primary coil we connected to the alternating current. Okay, and this one you can connect it to any electrical device. So let's say like a bulb. Okay, or maybe you want to connect it to the battery. Sorry, to the television. Okay, so any electrical device that can be connected. Okay, here, right? Okay, so and here this is the primary coils. Okay, And at here also, if they say they ask you for the voltage, this is called as a primary voltage, and this is the secondary voltage. Okay. Okay, so there are two types of transformer. Okay, just I told you just now, like say at the power plant, right? So after the generator produce the electricity, okay, you need to increase the voltage, okay, to be transmitted to the power station, okay, to the power station, and then after that it will be transmitted to our house. So you need to step up the voltage first, okay. Then after that, after it is like a power station or at the pilot, okay, that will decrease the voltage, okay, by using the step down transformer to send it the current or the electricity to our home. Okay, so there are two types of transformer. The first one is a step up transformer. This one to increase the voltage, okay, of the alternating current. And also the step down transformer is to decrease the voltage of the alternating current. Okay, so there are two types of transformers, step up and step down. Up increase, down decrease. Okay. Alright, so this is the symbol of the step up and the step down. So you can see here for the step up, the number of the coil here is much less than the secondary coil, right? So this one means when the coil increase means the voltage also increase. So from here you can see 12 volt. Okay, the input of the alternating current is 12 volt. Okay, but and then after it been transferred to the secondary coil, it will become 24 volt. So mean the voltage increase, right, from 12 to 24. So that's why we call it as a step up transformer. Okay, to increase the voltage of the alternating current, and we see also the number of coil also increase. So when the number of coil from the primary coil to the secondary coil increase, so it will increase the voltage at the same time, right? And for the step down transformer is to decrease the voltage. So you can see here from 240 volt, it will decrease to 24 volt. And at the same time, we see the number of coil here, okay, at the primary coil, okay, is higher than the number of the primary the number of the secondary coil here. So it means the voltage is stepped down. Okay, so what we can conclude here, okay, to increase the voltage, you need to increase the number of the secondary coil, if compared with the primary coil. Okay, so you can see it increase, right? So to decrease the voltage, okay, you have to decrease the number of primary coil, okay, in the secondary coil. So you can see the number of coil here is decreased from the primary to secondary if you want to decrease the voltage, right? So that is the two type of transformer. Okay, so this is the comparison, okay, between the step up and also step down. Okay, so the number of turn in the secondary coil is more than the number of turn in primary coil. So this one I already explained just now. And for step down, the number of turn in the secondary coil is less than the number of the primary coil. Okay, and you can see here also we already compared just now the voltage, right? So the voltage for the secondary coil here, this is much higher, like if you compare with the primary coil. Okay, and also this one step down, the secondary voltage is lower. Okay, and the secondary current is less than the primary current. Okay, and for this one the secondary current is more than the primary current. Okay, so this one because they use okay, this one is like opposite one. Okay, it's not same, we cannot use the Ohm's law here. Okay, so secondary voltage, so for this one we only increase the voltage but not the current. Okay. Right, so this is the step up and step down video. I don't know. I cannot play. Alright, never mind. Okay, because I have another video to show. Okay. Then I just move on to the next one. Okay, never mind. We see the video first. Alright, so this is the how does the transformer work, like I explained to you just now. Okay. I share the video first.
Before we look at exactly how transformers work, let's very quickly recap how they're used in the national grid. Most of our electricity here in the UK is generated at huge power stations, which are spread out all across the country. Once they've generated the electricity, it has to be passed through step-up transformers, which
Okay.
increase the voltage to around 4.
So just now, remember I told you from the power plants, right? They have to increase the voltage until 400,000 volt. Okay. So why is that?
400,000 volts. The purpose of this is to minimize energy losses as the electricity is sent across the country in a huge network of wires and pylons.
Okay. So here you can see there's a power transmission here, right? So for this one, why they need to increase the voltage? Because to minimize energy loss. Okay, because you know the long wire, right? Okay, the wire between the to transmit the electricity, the wire is very long. Okay, the wire is very long. So when the wire is very long, it means the resistance is very high. Okay, so the resistance is very high, so means the current when it flows, it has to overcome first the resistance in the wire. So mean there will be energy loss. Okay, because to overcome the resistance in the wire. So that's why we need to increase the voltage. Okay, so to minimize the energy loss, right? That means to overcome. So let's say after it used to overcome the resistance, there will be still a lot of voltage to be transferred, okay, to our home, to factory, like that. Okay.
Then once it gets to where it needs to go, like a small town, it passes through a step-down transformer, which decreases the voltage to around 230 volts, so that it's safe to use in our houses. So to sum up,
Okay, so you can see here wires, and after it be transmitting at the transmission, the power transmission, okay, then it will go to step down to decrease voltage. So here is 230, okay, volt. So every country they have different voltage, okay, usage. Okay, so let's say in Malaysia is 240, okay, but in Japan I think it's like 230 volt. Okay, and that's why if you bring like electrical device, let's say you bring a rice cooker, okay, and you go, let's say you go to travel, let's say to Japan, right, and you bring your rice cooker, okay, the rice cooker is from Malaysia, so means it uses 240 volt. Okay, and then you use it at the Japan, so let's say it need 230 volt. Okay, so means there's not enough of voltage there, right? So it will take a longer time to cook. Okay, because of the voltage, right? Voltage given to the to the rice cooker is not enough. Okay, because every country has a different input voltage. So that's why if you travel to another country, you have to see, right, what is their voltage, right? Because sometimes they say at the they say other country, when you went to the other country, when you go to other country, so let's say the voltage they use is 250 volt, then you use your electrical device there, let's say you bring your rice cooker there, so that your rice cooker will be it's not it's like will be like a short circuit there. Okay, because the voltage is higher than the rice cooker need. Okay, all right, so that is the difference. So this is actually different country, different input voltage. Okay.
the role of a transformer is to increase or decrease the voltage of electricity. To see how they do this, let's take a look at a single transformer. The grey stuff is a chunk of iron, which we call an iron core, and it connects the primary coil on the left to the secondary coil on the right. Now, how they work is kind of confusing at first, and in the exam, you're going to have to be able to use the correct terms properly, or you won't get the marks. So just bear with me as I explain it, but you might have to re-watch this bit a couple of times. The way we're going to approach it is to consider what happens to each part of the transformer step by step. The first thing to happen is that an alternating potential difference is applied across the primary coil, which causes a current to flow and generates a magnetic field around the coil.
Right. So here, like I said just now, okay, the alternating current flows. Okay, so when the current flows means there is a voltage flow also, right? So the alternating current flows here, okay, and you produce the it causes the current to flow, lah, right? Because of the voltage flows, so the current flows to the primary coil, okay, and you produce the magnetic fields around the coil. Okay, so and then because of the alternating potential difference here, it will produce also the alternating magnetic fields, or we call just now the various magnetic fields. So alternating magnetic fields is also same as the various magnetic fields. Okay, so the alternating magnetic fields of the magnetic fields, okay, the varies of the magnetic fields, okay, it's just same, right? If it flows through the secondary coil, okay, if it goes to the secondary coil, okay, by using the soft iron core here. So at here there we produce the induced EMF, okay, and produce the induced current at the same time, and the current will flow to the secondary coil, right, and light up the bulb. So let's say if connected to a bulb, it will light up the bulb.
Because the potential difference is alternating though, the direction of the current and thus the magnetic field will also alternate.
Alternate and varies in
This
the magnetic
alternating
field is
magnetic
same.
field in the primary
Okay.
coil induces an alternating magnetic field in the iron core. Because remember, iron is a magnetic material, so it can become magnetized if it's exposed to a magnetic field. Lastly, the iron core's magnetic field induces a potential difference across the secondary coil. And if it's part of a complete circuit, which it will be in a transformer, then this causes current to flow around that secondary coil.
Okay, that's the same that I explained
So
just
to
now.
summarize all of this, the transformer is effectively just transferring the current from the primary coil over to the secondary coil. But instead of the electricity just conducting straight across, it uses these induced magnetic fields. And the reason it can't just pass straight across is because the wires are insulated in plastic. So the electricity can't pass between the wire and the iron core. Now, the reason that we have to use all of this weird magnetic stuff is because it allows us to change the size of the potential difference. For example, in this one, which is a step-up transformer, if we put a 10-volt supply in, we'd get a 20-volt supply out. This is because there are twice as many turns in the secondary coil.
Okay, so for this
step
one,
the
later we
voltage
will
down.
learn how to calculate.
Anyway, that's everything for this video.
Okay. So we continue. Okay, we continue to the next one. Before I forgot, I already put all the notes, okay? I already put all the notes from chapter 1 until chapter 10, okay, at the Google Classroom. Okay, so you can check the notes here. Okay, this one is the notes that I'm using here. Okay, so you can check at the Google Classroom. Okay, and you can use that as your reference. Okay. If you want to print, it's up to you because there are like 387 pages. Okay, so I think for the chapter that we already have the notes, okay, the one that I give you the module, okay, so you don't need to print anymore. Okay, so either it's up to you to print, okay, or you can just read for your reference. Okay, so this one I already explained. Okay, two type of transformer. Okay, this is the video. Okay, all right. So what is the function of the transformer in a home electrical appliance? So what's the function? The transformer is used to increase or decrease the potential difference of alternating current. So let's say your phone, your handphone. Okay, so your handphone, if this does not use 240 volt, right? Sometimes they only use like 6 volt, okay, or sometimes you use like a 20 volt, okay, to charge the phone. Okay, so you don't need like 240 volt to charge your phone. Okay, so that's why we need to have a transformer. Okay, so it will decrease the voltage so you can use to charge your phone. Okay, so example, so for this one, say it said the electrical source that provide to our home in Malaysia is 240 volt. Okay, so the output of a mobile phone charger is 5 volt. So the transformer is used to decrease from 240 volt to 5 volt. Okay, so this is the function of the transformer. All right, so the next part is you have to know how to calculate. Okay, how to calculate the coil. Okay, how much you need the coil for the secondary voltage. If you want the let's say you want 5 volt just now. So what is how many turns that you need to put at the secondary coil? Okay, so you need to calculate that one. So the output voltage produced by a transformer is dependent on the input voltage and the ratio of the number of turns of the primary coil to the number of turns at the secondary coil. So this is the formula. Okay, and S over NP is equals to Vs over Vp. Okay, so this is the formula how you want to calculate the output voltage or the input voltage or what number of turns in primary voltage and primary coil and also the secondary coil. Okay, and this is a formula you need to remember, and also this is the formula for the efficiency of the transformer. Okay, so the output divided by input you times by 100. Okay, usually the efficiency you calculate in the percentage. Okay, so let's say if I say just now, okay, I have the alternating current here. Okay, right, so this is the wait for a moment. Okay, and I put here, I connected it to the bulb. Okay, so now, okay, my power here, okay, my power here at the primary coil is let's say um 20 watt. Okay, 20 watt, right? And then after you transferred, right, all the magnetic fields, okay, and then the secondary induce the current. Okay, so the power here I got, let's say, like 15 watt. Okay, so here is the input. Okay, and here is the output. Right, so the secondary will be the output. Okay, the primary will be the input. Okay, so let's try to use the formula. Okay, so the power output, remember the power, the unit for power is watt, right? It's watt. Okay, so teacher, if they didn't give you the power, how you want to calculate the power, you can use the formula P is equals to VI. Okay, means you have to know the voltage and the current so you can calculate the power. Okay, so this one also same. P is equals to VI. Okay, so to calculate the power, must know the voltage and also the current. Okay, so let's say for this one, they already give you the watt, okay, the power here. So the output is 15 watt. Okay, and the input is 20. Okay, then you just times 100, right? Okay, so you will get 75%. Okay, so means the efficiency of the transformer is 75%. Okay, means there will be a loss of energy here during the transmission. Okay, so there will be there will be a loss of energy here during the transmission. So that's why the efficiency only 75% only. So let's say if 90% is much higher, right? So mean there will be less less of loss of energy, okay, to the surrounding. Okay, so you have to see the efficiency. It's just seeing that when you buy the electrical device, you have to see the efficiency also. Okay, you can see there's a 4 star, 5 star there, right? So means it's a 4 star, it's a safe energy. Why is safe energy? Because there is less energy lost to the surrounding. So mean that more energy we use, okay, for the electrical device. So you can save the energy. Okay, so that's why when you buy the electrical device, you can see how many star is there, right? Let's say 4 star, 5 star. Okay, usually they already state that. Okay, so for this, let's say for this transformer, only 75%. So another 25%, okay, that will be lost to the surrounding, the energy there. Okay. So the ideal transformer is a transformer which is 100% efficiency. So what does it mean? So let's say if the input here 20 watt, the output also 20 watt. So there will be no loss of energy to the surrounding. So that is the ideal transformer. We call it as the ideal transformer. But it's very hard, okay, to happen in the real life, because air wire also they have their own resistance, and we need to overcome the resistance, so there will still be a loss of energy to the surrounding. Okay, but this is the ideal transformer, which means 100% efficiency. There is no loss of heat energy or other energy to the surrounding, so all of the energy being given uh, is used to light up the bulb. Let's say that's the example. Okay, so that is the ideal transformer. So how you want to improve the efficiency of transformer? Okay, just now when let's say I just calculate, right? Only 75%. So how can I increase the 75% of the efficiency? Okay, so then ideal transformer cannot exist. So just I said just now, it cannot exist. Why? Because it will loss, especially as heat energy, okay, when the transformer is functioning. So just example, like if you use your phone, right? If you use your phone or use your electrical device, okay, for quite some time, okay, so you can see it become hot, right? So it means the same as transformer also, okay, it will become hot, okay, because the alternating current flows through it, right? So it will become hot, so it will become the heat energy. So that's why there is no such thing as the ideal transformer. Okay, but we can increase the percent of the efficiency. Okay, so the sources of energy loss and the ways to reduce the lost energy are as displayed below. Okay, so the first one, source of lost energy. So the primary and secondary coil have resistance. So heat is produced when the current flows through them. So this one I just explained. So how to overcome it? Okay, you use the thick copper wire, right? Because copper wire, if you compare the copper wire with the conductor wire, copper wire has a low resistance. Okay, but it quite expensive. Okay, even at our house we didn't use copper. Okay, if you use the copper, yes, you can use. Okay, but I mean you have to pay more. Okay, so for the copper wire, it's quite expensive. Okay, and because of the low resistance, right? If you compare to the like the conductor, okay, or nichrome wire. Okay, and also you can increase the cross sectional, because the thick wire means it increase the cross sectional. Okay, so let's say if I have this is my wire, this first wire, and my second wire is like this one. Okay, so you can see the cross section here is much higher, right? So means the electric current is easy to flow. So means the resistance is low here. So you have to increase the cross-sectional wire, right? And then the changing magnetic fields in the soft iron core induced as a current known as eddy current in it. So this will causes a heat to be produced in the soft iron core. So what you can do, we use a laminated core of thin soft wire. Okay, so laminated means there will be that loss of heat of energy will decrease. Okay, so this will increase the resistance of core, right? So this using the laminated core means you make it like a layer there. Okay, so you just arrange the soft iron core in the layer form. So that we call it as the laminated core, right? and the leakage of magnetic flux cause some energy not to be transferred. Okay, what you can do, you wind up the secondary coil on the top of the primary coil. Okay, so you put it, okay, one at the top and one at the below. Okay, so this is how you increase the efficiency of the transformer. Okay, eddy current, so this is the ways to reduce. Okay, so the resistance of the coil increase, power and loss as a heat increase, right? So the eddy current cause, okay, the power loss of as heat increase. So for use why we a soft iron core, so the power loss to the magnetize and demagnetize the core increase. Okay, so the both primary core and secondary one are on the same arm. So the power loss due to the magnetic flux leakage decrease. Okay, so that's how that's for the transformer. So now I have a few example, okay, how to calculate the uh, transformer. Okay, let's see the first one here. Okay, diagram 28, right, shows a transformer that used to light a bulb. Okay, so remember you use the alternating current here. So which of the following statement is true about the transformer? Okay, so you can see the number of the primary coil, okay, is lower than the primary coil. So this one is step up or step down. Okay, anyone want to try? Is it step up or step down? Yes, very good. Okay, so this is the step down. Right, so means the answer for A and B is wrong. So how you want to calculate the voltage across the bulb? Okay, so remember just now we learned the formula Vs over Bp is equals to Ns over Np. So Vs is what? Vs is the voltage at the secondary. So here, so this is the secondary coil, this is the primary coil. The one that connected to the alternating current is the primary. Okay, so the other side here is the secondary. Alright, so voltage of the secondary you need to find Vs. Okay, and the voltage of primary already given 240 volt. Okay, and the number of turn in secondary is 50 and the number of turn of the primary is 200. Can you try to calculate for me what is the voltage for secondary by using your calculator? Just cross multiply. $60. Okay, so 200 Vs. Right, you cross multiply it like that. So 200 Vs. Okay, this one is 200 Vs equals to 50 times 240, right? So you will get 50 times 240 divided by 200. So you will get the answer 60 volt. Okay, so you will get the answer 60 volt. Alright, so good. Okay, so let's say for the next question. Okay, try number 29. So this one I already explained. The answer is B. Okay, for this one from the power station or the power plant, right? So this one I already told you have to increase the voltage, okay? And then after that, when you reach our house, you need to use the step down transformer. So the answer step up, step down. Yes, very good. Okay, for question 1038, okay? Try to answer for this one. They ask you which terminal that should be connected, alright? so it can produce the 12 volt. Okay, use the formula NS over NP equals to Vs over Vp. So whether it should connected from P to Q or P to R or P to S or P to T. Okay, so what you have to do, you have to find first what is the number of turn in the secondary coil. Okay, and it needs to produce the 12 volt at the secondary coil. Right, so please try first. Okay, remember I told for you just now, okay, this one is the 240 volt, right? So you can see this is the symbol alternating current. So this one should be a primary, this one should be a secondary. C, alright, type Jin, you got C. Okay, any other people want to try? Maybe you got different answer, teacher, I got different one. What is the number that you, number of turn that you get, Jin? 150. Okay, 150. Others? Who want to try? Yim Ziyu, Lam Yan Hei, Chen Juyan. Yingxi Yu Wu Gui. Did you get the answer? Teacher, shouldn't be VP over VS. It's same. Doesn't matter, it's same. You can still get the answer. As long you use the same ratio. Okay, so if you use a secondary ratio, secondary to primary, so at this side also should be secondary to primary. So you get the answer, Yingxi. So what is the number of secondary here? This one you need to find, right? NS. Okay, and the number of primary is 3000. Okay, and the voltage of secondary is said it have to light up the mantle, like 12 volt, right? So the voltage secondary is 12, the primary voltage is 250. Sorry, it's 240. So you just cross multiply it. Alright, so 12 times 3000, divide by 240, so you get 150, right? So 150, if you connected P to Q is only 50. So connected P to R is only 100. So 150 is connected to P to S. So 50, 50, 50, 150. So good, the answer should be C. Okay. So let's try to for this question. So it said here the diagram below shows a simple transformer with bulb light up at the normal brightness. Okay, so what will happen if the alternating AC input is replaced with a 3 volt battery? So can the transformer function if I put the input voltage is the direct current? No. So what will happen to the bulb? D, yes, the bulb will not light up. Okay, only AC current. Okay, the last one, this one you need to find the output voltage. So output voltage actually is the secondary voltage. Okay, if input voltage, that one is a primary voltage. Okay, so again we can use the NS over NP divide by VS over VP. A. Okay, so let's see the answer. Okay, so the number of secondary here, right? NS is 1200 and the NP is 200. Okay, the number of turn in primary. Okay, the voltage, the secondary voltage is the one you need to find. VS, the output voltage is the secondary. And then the input is 240. Okay, so you just cross multiply 240 times 1200 is equals to 200 VS. 240 times 1200 divided by 200. So you will get 1440. Okay, so correct. So the answer is A. Okay, very good. Okay, so I will stop now. Okay, and I know we still have like tutorial, right? So I already assigned for you, okay, a tutorial in Google Classroom in GC. So I want you to answer that one. That one is 6.1 tutorial. Okay, and then tomorrow I think we still have like 2 period of tutorial. So I will discuss all the exercise that I gave, the module chapter 5, the tutorial for chapter 5, and also the tutorial that I gave today. Okay, so we will discuss that all during the Google Meet tomorrow. Okay, so I see you tomorrow. Okay, so please answer the question. Okay, you can print or you can just write your answer in the test pack, right? If you don't have a printer at home. Okay, so we discuss all that tomorrow. So I see you tomorrow, class. Okay, so please do the question that I give in the Google Classroom. Okay, so see you tomorrow. Okay, bye. Thank you. Thank you. Welcome. Welcome.